Hello, I'm Anand from Object Automation System Solutions. This session is an introductory session for the joint program with the National Institute of Electronics and Information Technology, Calicut. In this session, what I'm going to explain is how the modern full stack applications are built and the technologies used in real world projects. That's what I'm going to explain. I'm going to demonstrate. And also I will cover the architecture, development process, and the industry practices. What are the architecture are there, development process are there, industry practices are there. That's what we are going to see. Why full stack development matters today? Why full stack development matters today? Applications are distributed and cloud native. So first point. Then user expert real-time performance. Then system must scale dynamically. System reliability and mandatory. These are the things. Before seeing that points, why full stack development matters means what before that, what is full stack? Modern applications are distributed and cloud based. Now all the modern applications are distributed and cloud based. Cloud based means anyone can access from anywhere. That's what the cloud based. In cloud, the application or system will be deployed. Then why the full stack matters today? Because application need to handle large number of users and provide fast performance. Like application should be able to handle the traffic under all large number of users, provide good performance or faster performance. Then where it is used in banking applications, e-commerce platforms and all, this full stack development matters today. This is the real-time example for full stack application. One more example we can say it as online event registration system. During any event which was conducted in the college, the thousands of students may register simultaneously. At the time, system should handle the traffic, validate data to prevent harmful or wrong data. And also, the data is to be stored and remains responsive. The real-time example, online event registration system, we can say how the modern application are distributed and cloud. During any event registration, any event conducted by the college, thousands of students may register that event or register for the event simultaneously. What the system, the application should or must handle the traffic, validate data, store records, and remain responsive. That's what the full stack application. Today, what the application not running in a single system. They are deployed in cloud, divided into multiple services. That's what I'm saying the example. What the user expects the real-time performance. Then we can say one more example as movie ticket booking or booking for a travel in bus or train. How the instant payment occurs, the transaction occurs. We can able to book the movie ticket or bus ticket. That's what one more example. The system must scale dynamically. And also, what that means, the system must scale dynamically means the system is what? The application must scale dynamically means that means the system able to handle the traffic. Like the example I said, for the event, thousands of students may register simultaneously. At the time, the system able to should handle the traffic. That's what the system must scale dynamically. Then security and reliability also very important. That also matters. Then application must protect the user data. This is also an important one. The application, whoever the user using the application or system, that should protect the user data. That should ensure the user data should be protected. And the work without failure, that also is important. It should be like the user-friendly one. Next, end-to-end development life cycle. End-to-end development life cycle means the software development life cycle. How the software application or system developed, under what way it is developed, it is developed. That's what the end-to-end development life cycle or software development life cycle. In this, there are 7 stages. Requirement gathering analysis, requirement gathering analysis, design, implementation, coding, testing, deployment, maintenance. These are the 7 stages are there. Before that, what is this software development life cycle? It is like, it is useful to, it is the steps or stages how the software is built. That's what the software development cycle. How the system was built, or how the system we are going to build. It's what the software development life cycle. Then why it is used, the software development life cycle? For the organized process, we are using the software development life cycle. And also we can reduce the errors. Some of the errors we can make without this. For that, reducing that error, we are using this software development life cycle. Then where it is used? This was used by every company. All companies are using this software development life cycle. The software development is not only the coding, it also follows the structured life cycle. That's what the software development is. It not only depends on coding. It's not only the coding part, it follows the structured life cycle. In that first stage is what? The requirement analysis, whatever you have seen. Requirement analysis means what we understand where the user, what we understand, what the user needs, or we can say understand what the client or the user actually needs or actually want. That's what this requirement analysis. They will gather the information from the client side. What are the things need to be in that applications? Whether it will be a login module, and what are the tabs to be there. Then like any particular things should be there, or any chat icon. Those things are the gathering the information. What are the modules need to be take place in that application or system? That's what the requirement analysis. What it is means gathering the information, understand what the client or the user actually needs. UI or UX design. UI or UX design, what means? The UI or UI means user interface. What the user actually seeing, that was the UI. Visual is what the user visualizing. That is the UI, user interface. This UI UX design is the designing user interface for better experience. These are the 2 more stages, like the UI UX design, API design. API means like how the 2 systems communicate each other. That's what the API, application programming interface. Example, we can say weather app. How we are getting the weather data in our mobile. Using the API only, our mobile company providing us the weather data through this API only. This how the system communicate with each other. In simple, we can say how the front end and back end communicates. That's what the API. Then database schema design. How the data will be structured and modeled. This is what the database schema design. This design only comes under the UI UX design, API design, database schema design. Plan like UI UX design. how to design the user interface for better experience, better experience. Then API design, how the front end and the back end should communicate that thing. Then database schema designs, how the data, all the data to be in what structure it to be stored. That's what the database schema design. This all will comes under the second stage of the design. The second stage of the software development cycle, which is design. Then development, writing a clean modular code. That is what the development. Developing the code. Then next part is testing. Testing is used to ensure the quality of the system or application. Because some bugs will found after developing. The testing needs to be done to reduce bugs, to ensure the quality of the system or application. That's what this stage, the testing stage. Then CI/CD development means continuous integration and continuous development. Why it is used means automatically build, test, apply the code. That is what this CI/CD deployment. The deployment, it will comes under the deployment stage. This is sixth one. Then monitoring and maintenance. After releasing the application, we should track the performance of the application, should monitor and maintain the application. Because if any issues find, we have to resolve it. For that, we have to monitor the application and we should maintain the application. This is the seventh stage. These are the 7 stages like requirement gathering analysis, development, design, development, testing, then deployment, monitoring, and maintenance. These are the 7 stages. We can say the example for this is college ERP system, how it is designed. And there will be like login module, attendance, then mark modules, like that. After that, it will be hosted in a cloud platform. So the students can access it from anywhere. That's what I say. How the modern application is distributed and cloud-based. Next, from idea to production. This is what we have seen. Next is software architecture. Software architecture what means high-level blueprint. Blueprint means in generally what we can say, what we can hear. Blueprint means what we come to know. Blueprint for a house, like we are going to build a house means like in what dimensions kitchen will be, what dimension hall will be, what dimension portico will be, what dimension bedroom will be. Like that, the blueprint. Like this, similar to that, the software architecture is a high-level blueprint. What it defines means it will define the system structure, components, how they interact to meet the business and the technical requirements. That is what the software architecture. The software architecture will define the application or system structure, components, how they interact to meet business and technical requirements. In that, there are types or some types are there in software architecture: monolithic, microservices architecture, MVC architecture, layered architecture, client server architecture. These are the types are there. In monolithic architecture means the entire application is built as a single unit. That is what the monolithic architecture. Monolithic architecture is like single application. All the things are built as a single one. That is what the monolithic architecture. The single application. Simple, you can say it as single application. Why it is used? It was the simple development. You can develop it easily. That's what it is used. Monolithic architecture is used. By using this, we can build a small apps. Example, we always have seen college ERP system is the example for the monolithic architecture. Then microservices architecture. What it means? It divides the application into small independent services. What this monolithic architecture will do? It means the entire application built as a single unit. That's what the monolithic architecture. For small apps, it is good. Microservice architecture, what it will do means it will divide the application into small independent services. Example, real-time example, we can say Amazon food delivery app like Swiggy and all, we can say it as example. That's what means their monolithic, it work as a single unit. Here, each service works separately. Means independently, each service will work. If one server fails, other continue working. That's what this microservice architecture. If any one server fails, others will keep going on, keep continuing their work. That's what the microservice architecture. What it will make means it will make the system scalable and flexible. That is what the microservices architecture. Then MVC architecture. This is the most important and most useful one. MVC is an architectural pattern that separates an application into model view controller. This MVC abbreviation is model view controller. To improve maintainability and scalability, this architecture is useful. Modern in the sense, model means database. View means whatever the user seeing, the user interface, the front end. Then controller is about the logic, backend things, the controller. Real-time example, what we can say is when the user enter the username and password, what the user will see. The user will see first the login page will see. The user will see. Then the controller check the credentials. Then model interacts with the database. That is for the MVC architecture. Model view controller. What is the advantage? This separation improves maintainability. That's why the MVC is used. Then layered architecture. Layered architecture divides the previous one, whatever we have seen. The MVC separates an application into model view controller. Like that, the layer will divide the system application into multiple layers. The presentation layer is what? UI. Business layer is logic. Data layer is database. We can say the real-time example as banking application. In banking application or banking system, the UI layer means the user enters the detail. That is what the UI layer, the presentation layer. Then the business layer will validate the transaction. The logic contains logic. Then the data layer, it will store the account details at the database. That is what the layered architecture. Then client-server architecture. Client-server architecture consists of client and server. The real-time example, we can say the Facebook, YouTube, web applications are example for client-server architecture. In this, browser acts as a client. Server will process request. If anything we browse, it will act as a client. Server will process the request and send response back. That is what the client-server architecture. These are the types of software architecture. In the software architecture, how the system is structured. That is what we have seen. The software, what is software architecture? How the system is structured, how the system or application is structured, or blueprint of the system. We can say. In this, we have seen the types. Then, for that only, we have seen the example, real-time example, web application, Facebook web application, YouTube web application, browser act as a client, server process request, then send the response back. Application architecture. What is application architecture? Previously, we have seen software architecture. Now the application architecture is like the flow, how the modern application works. That's what the application architecture. This is the flow: user, front end, API layer, backend, database, cloud infrastructure. User means we or any real-time users. Then front end user interface, the API layer for communicating. Then backend logic, database for storing the details. Then cloud infrastructure is what? Deploying. That is what this application architecture. In this, we have technologies for both front-end and we have front-end technologies and programming languages are there in this application architecture. We are using for building an application. What this front-end development? What are the technologies for user interface? What are the technologies for user? HTML, CSS, JavaScript, and also some of the libraries and the frameworks. What this front-end development was, this user interface, this part means whatever the real-time user see. This was the front-end things, what the user sees and they interact with. That is the user interface of an application. Then in that we have technologies like HTML, CSS, JavaScript. Then there are some frameworks and libraries. In this, HTML means used to create a structure of the web page. For an application, for creating the structure of the web page, the HTML is used hypertext markup language. In that, there are elements. We can create the form, and then we can create the link. There are elements are there. Then CSS is used for styling that web page, by styling that user interface, whatever we have created. The cascading style sheet is used to design or style the UI. Then JavaScript. Why it is used? JavaScript used to add interactive and dynamic behavior between the user and the system. This JavaScript is used as a both front end and back end. Then what are the libraries are there? React is one of the library. We can differentiate the library and the framework. What is library? What is framework? Library means like it will contain certain functionality only. That is what the library. Frameworks means all the inbuilt functions will be there. That is what the difference between these two. Library is the reusable code. It will contain only certain functionality. Framework, what framework means? All the inbuilt things will be there. That is what the framework. Then the programming languages. We can say the React means used to build the reusable UI components. Reusable UI components. In Gmail example, in Gmail, the logo is one component. Then inbox is one component. Then sent. Then starred, spam, and all. Each is separate component. That's what the application will be built. Then Angular framework is there. This React is launched by Facebook. Angular is launched by Microsoft. What this Angular framework? It is a framework. What it will provide? It will provide the complete structure for the front-end development. Then one more framework is there, Vue.js. It is the lightweight and easy to learn for the front-end development. These are the libraries and the frameworks in front-end technologies. In back-end development, what are the things are there? Programming languages. Why this back-end development is used? It is used for, already I said, it is used for handling the business logic and processing data and managing communication between the front end and the database. what it will do means backend will act as a bridge between the front end and the database. Front end means what? It is the user interface, whatever the user sees. Then database, where our details, account details, or what data getting stored. That is the database. This backend development is responsible for handling the business logic, processing data, managing communication between the front end and database. Then what are the programming languages are there? Programming languages mean what? We are instructing something to perform to the computer or machine. We are instructing the machine to perform something. That is for the programming language. This language Java, this is the programming language. This is the intermediate between the machine and the human. What are the there are programming language? Among the programming languages are Java, Python, C, C++, C Sharp, JavaScript also used as a both front end and back end. In Java, we can say why it is used. Used to build scalable and secure enterprise applications. What is Java? It is one of the programming language, robust, high-level robust language. High-level robust language. It across various domains. Then platform independent. Platform, why they are saying Java is platform independent? Write once, run anywhere. We can write from one OS, run in another OS. Can write anywhere and run anywhere. That's what the platform independent. Then OOPS based. Java is OOPS based. Then open source means free of cost. There are like in Java, 3 parts of the Java are there. Standard edition, enterprise edition, micro edition. For standard edition, we can say example as standalone application. Example, calculator. Standard edition, example, you can say calculator. Others won't access our calculator. It will be worked in the same system. Then enterprise edition. Example, we can say e-commerce sites are the enterprise application edition. Anyone can access from anywhere. That is what the enterprise edition. Micro edition. Micro edition means mobile applications are micro edition. Mobile applications like Swiggy, Amazon, Flipkart, all mobile apps are there. And that all come under the microservice, micro editions. Then there are also the components of Java, this main components of Java. Java development kit, JDK, JRE, Java, JVM. Java development kit used to run our develop program. Then the Java runtime environment used to Java runtime environment, it will contain the predefined files and the libraries. Java virtual machines for memory allocation execution. These 3 are the main components of Java. Then Python. Python is the easy one. It is also a robust language used across various domains. It is also OOPS based, open source. It is used for fast development because easy to understand. Python language is easy to understand. It is why it is used for fast development and APIs. Then the JavaScript also used as a programming languages. Used on backend with Node.js for building APIs. JavaScript is used in backend. Then backend frameworks and technologies. What are the backend frameworks and technologies? Spring Boot for Java is used to build REST APIs and microservices in Java. Then Django framework is there for Python. Some of the frameworks for Python is Flask is there, Node.js is there. Spring Boot, I already said, is to build REST API and microservices in Java. Django is the full stack framework with built-in features. I already said framework is the with the built-in things, inbuilt things. Flask is the lightweight. For smaller application, we can use the Flask framework. Then database. database, what will do? It will store our data, manage our data. That is what we should to store and manage application data. We should to manage and manipulate database, relational database. That is what the database. What this database will do means stores and retrieves the data. We can say that for the modern application, how the modern application works, we can say real-time example, movie ticket booking system. When the user select the seat, how the user selecting the seat? Through the user interface, whatever he sees. That is what the front end. For that, we can use the framework or technologies. HTML, CSS, front end technologies, or React libraries. React is the library, not a framework. We can use for the front end. Then back end. Back end checks the availability. Back end will check for the availability of the seats. Then what the database will do? It will update the booking. If there is a 10 seats, if anyone book the seats, it will backend will check for the availability. Then after booking the seat, the database will update the bookings like 10 to 9. It will be changed to 10 to 9. Then payment gateway confirms transaction. Cloud server is used for hosting the application. That was the cloud infrastructure. Backend design and API engineering. What is this backend design and API engineering? Designing reliable APIs. That RESTful architecture, proper HTTP status codes, error handling and validation, authentication and authorization, secure data handling. Designing reliable APIs. In this, RESTful architecture is there. What is RESTful architecture? Before that, this good architecture, what will do mean the system failure to be avoided. When the traffic increases, the system failure to be avoided. That's what the good architecture. Then we will see the backend API design. Already said, backend will handle the business logic. API is the how the system communicate each other. Is how it is act as a bridge between the front end and back end. That is what the API, application programming interface. RESTful architecture. What this RESTful architecture will do means it will use standard HTTP methods like get, post, put, delete, and all. It will use. Get means it will fetch the data. It will retrieve the data. Post means it will create a new resource. Put means it will update the existing resource. There is one more method is there, patch. Patch what will do means it will partially update the resource. Delete is for deleting the resource. And the resource means deleting the entries, whatever we registered. This is what the RESTful architecture. Then proper HTTP status codes. Proper HTTP status codes means there are more status codes are there. Like 200 is for success response. If we are if we are able to fetching the data, it will be the status code will be the 200. Means the success response. We are not able to retrieve means request or no resource not found. That is what we will get. The request or resource is not the request or resource not found. 404 error will be shown. Then 500 is the internal server error. Any server cache or for that 500 status code will be displayed. There are more status codes are 201 for like the new resource is created using the post method. the 2.0 will be there. Either there are more number of status code are there. 400 also there, internal server error. Then error handling and validation. What is this error handling and validation? Error handling and validation means validating the inputs to prevent wrong and harmful data. What means validating the inputs to prevent wrong or harmful data means if someone try to enter the duplicate credentials, that is what the system will do means system will validate the inputs. Inputs means the user input fields. Like if you open the Gmail, like trying to sign into Gmail, there will be like login page. The sign in page will be like username and password. That are the input fields. We are trying to enter the duplicate credentials in any one of the fields, like username or password. The validation message, error message will show. That is what the validating the inputs to prevent wrong. Why it is validating? We are validating to prevent wrong or harmful data. Any duplication or any wrong data or harmful data. For that, we are using error handling and validation. Then authentication and authorization. What is this authentication and authorization? Verify the user identity and control access level. Like we can say, what in simple authentication means, we can say example login credentials is the authentication. We are verifying the user identity. Like if we enter the username and the password, we will verify whether this person is already signed up or already registered in this site. It will verify the user identity. That is what the authentication. Authorization. Authorization controlling the access levels. Controlling the access level means what the user allowed to do. Like we can say example in college website, there will be the student login and the staff login will be there. The student only able to log into their module. The staff only able to log into the staff module. That is what the authorization, what the user allowed to do. Then secure data handling. This is the important one. Encrypt sensitive information. Encrypting sensitive information means like while we entering the password will be hide. Like it will be password mask. That is what the encrypt sensitive information. Securing the data handling. The user's information to be protected. Already said user, this is whatever system, it should ensure the user data should be protected. Example, we can say in e-commerce application, API, already said API is the communication between front and back end. What is this? In this, what the API will handle responsible for? Order creation, product retrieval. Order creation means like if any user or me going to the Amazon site searching for any product, then the product particular specific product will be visible, will be shown. That is then after that we verifying all the things, we will make it to add to cart for buying. That was the order creation. Product retrieval. After searching any specific product, that product page needs to be loaded. This was the product retrieval. Then user updates. Clean API design, what will do means it will ensure front end work smoothly. This clean API, what will ensure means it will ensure front end to work smoothly. That's what this backend and the API design. Backend design and the API. The RESTful architecture. In the RESTful architecture, we will use the methods, some of the HTTP methods like get, post, Through that only we are fetching the data. If we are searching for any product in the e-commerce site, how we are getting, that is the get method. Then if we submit any form, that is the post method. For this API, there are tools like Postman are there for the API testing. The real-time example I will say for post order, for get product search, for put updating the profile or any address. If you are moving to some new house, we will update the address. That will be the put method. It will update the existing resource. We will update the existing address with the new address. That is what the put method. Then after add to cart, we can remove it. That is also delete method. I will say well-designed API ensures smooth front-end and back-end communication. Next, database design and optimization. What is the importance of structured data management? Normalization, relationship, one-to-one, one-to-many, indexing for performance, query optimization. These are the importance of structured data management. You can see one by one. What is normalization? Before that, what is database? Already said, database is used to store or manage data. It is used to store, manage our data or manipulate data. In that, we can create the table. First, we have to create the table and the input fields, whatever the fields there. First, we have to create the database, then the table, then the columns and rows. Table will be in the format like columns and rows. First one, normalization. What this normalization will do? The importance of structured data management. What the normalization will do? It will remove the duplicates. This is what the normalization. Then relationship, one-to-one, one-to-many. What it will do? Like this, I already said, normalization will remove the duplicates. How we will remove the duplicates? We have to organize it. We have to organize the data. It will lead to the avoid duplication. That is what the normalization we have seen. The part is relationship. One-to-one, one-to-many. That means what? Defines how table connect. If one table is okay, if more than one tables, how the two table is connecting. That is what the relationship. Normalization is about the removing duplicate by organizing the data. That is what the normalization. Relationship, one-to-one, one-to-many means more than one table, how the tables connect each other. That's what the relationship. Next, indexing for performance. Indexing for performance means what? Means like improving the speed of the searching data. If I log into the e-commerce site, if I search for any specific product, it should retrieve the data faster. That is what the indexing. While we indexing, what it will do means it will improve the speed of the searching data. Through indexing, we can retrieve the data faster. That is what the indexing. Indexing for performance. Then next, query optimization. Query optimization means like writing the efficient query. Writing the efficient query for faster response. If you write the efficient query means only we will get the faster responses. If you not write the efficient query, we will not get the faster response. That is what the query optimization. Like this database, the query, we will write the query and execute it for creating the database table and inserting the values, then updating the records for that. We will use the queries to write for creating all the things. Example, we can say in event management. Example, event manager, we can say user register for events. If schema is poorly designed, already said, the efficient queries will lead to faster response. If the schema is itself poorly designed, the system slow down during the peak traffic. Always say the system should be able to handle the traffic, more number of users register or into the site simultaneously, should be able to handle the traffic. In those things, this also the important. The database design also important. We have to write the efficient queries to for faster response. We have to write efficient query to the system handle the traffic smoothly. For that, schema is poorly designed. The system slow down during the peak traffic. The schema is properly designed, like efficient queries like that, the system will able to handle the traffic. Next, library versus framework we have already seen. Library is a collection of pre-written functions. I already said it is a certain functionalities that can use to perform some specific task. The framework is the all inbuilt functions will be there, all inbuilt things will be there. The complete structure for building an applications. That what we have seen, the content libraries, React, jQuery are the content frameworks, Angular, Vue.js, backend Java frameworks, Spring Boot, Spring MVC are the Java libraries. Some of the Java libraries, Hibernate, Lombok. Then Python frameworks, Django, FastAPI, Flask are there. Development tools. What are the development tools are there for this system, for building a system, for developing an application or system? The code editors or integrated development environment. Some of the code editors like Visual Studio Code is there, IntelliJ IDEA is there, Eclipse IDE, which is used for Java, mainly used for Java. Then build tools, Maven and Gradle are there. What is Maven? Maven, these two are builder tools means Maven is the project management tool or dependency management tool. For some of the application, the dependency we need, for that we will use this builder tools, Maven and Gradle. Front-end development tools, React and Angular also front-end development tools. Then back-end development tools, we already say the Java, Spring Boot. For the API testing, the Postman is there. For Python, Django and FastAPI frameworks are there. For database tools, there are MySQL, Workbench, MongoDB, then SQLite are there. Then next, scalability and performance engineering. What is scalability and performance engineering? Designing a system for high traffic. For high traffic, how to design the system? One thing, load balancing, horizontal scaling, caching mechanism, content delivery networks. These are the designing system for high traffic. What is load balancing? Like load balancing means, if I already said, the thousands of users simultaneously register means the system should be able to handle the traffic. The load balancing is what means, like the traffic should be distributed. How we can load balancing? We can scale it by adding servers, more servers. We can handle the traffic. We can, using this load balancing, we can distribute the traffic. How we can distribute the traffic? By scaling add servers, by adding servers, more servers. we can be able to handle the traffic. Through this load balancing, what we can do is distribute traffic across multiple servers by adding more servers. Then next one, horizontal scaling. Horizontal scaling is same, adding more server when traffic increases. Previously, load balancing, how the traffic distribute. That is what the load balancing. Scaling adds servers. Horizontal scaling means adding more server when traffic increases, when the users increases. Then next one, catching mechanism. Catching mechanism means storing frequently accessed data for faster response. The frequently asked like accessed data will be stored as a catch. When the user asks for anything, it will display as faster. The response will be faster. That is what the catching. Then CDN. CDN means content delivery network. What is content delivery network? It will deliver the static content from the nearest location to the user. That is what the content delivery network. What we can say, example, the real-time example, what we can say for this scalability and performance engineering. We can say the example, real-time example, during a flash sale on an e-commerce website, the traffic will increase 10x. The cloud auto scale servers, load balancer distribute request, scalable system prevent crashes. If the system not able to handle the traffic, what will happen means the system will crash. That is what if we fail to, if we are not implemented the designing system, the height to handle the traffic, the system will crash. For that, we have to do this, the load balancing, horizontal scaling, catching mechanism, content delivery networks. This and all we have to do. Through that, what are the things will do? The load balancing will distribute the traffic. The horizontal scale will adding more servers when the traffic increases. The catching, what will mean, frequently accessed data will be stored somewhere and for the faster response. Then content delivering static content from the nearest location to the user. That is what the scalability. Then DevOps and DevOps CI/CD integration, continuous integration and development. There are Git bridging development and deployment. There is Git version control, branching strategies, CI/CD pipelines, Docker containerization, cloud deployment, monitoring and logging are there. What is DevOps? DevOps, like whatever we have seen, is DevOps, development plus operation, automates development and deployment. Through the Git version control, what we can push our code or pull the code. The code is tested and deployed automatically. This is the Git version control. Git is what? Track and manage the code changes. We can push or pull the code. We can collaborate also. Then branching strategies. In this branching strategy also there, develop features separately before merging. Can merge according to the code changes. Then CI/CD pipelines. Automatically test and deploy codes. There is an application, Jenkins. This is for automatic. It will automatically test and deploy code. Then Docker package application with all dependencies. The cloud deployment, cloud from AWS for monitoring and logging. It will track errors of the system health. Example what we can say for this, when the developer pushes the code to the GitHub, like this GitHub means it is a remote machine. In our system, the project folder code, that is the local machine to remote machine. faster and error-free releases. Then security in full stack systems. Building secure applications. For building the secure application, there are JWT-based authentication, role-based access control, password hashing, HTTPS encryption, rate limiting are there. For building the secure application, there are like JWT authentication, then role-based access, password hashing, HTTPS encryption, rate limiting are there. Why security matters? Security is important. Why? It will protect the user data from hacking. Authentication, I already said, it will verify the user identity. What the encryption will do, it will protect the data. First, we will see the JWT authentication. What this will do means, we'll use secure tokens to verify the user identity. The JWT authentication will use secure tokens to verify the user identity. Then role-based access, already said authorization, different access levels, what the user allowed to do. One more example, admin or user. In whatever I said, like whatever example I said, the student, the staff, before I said. Then password hashing, store encrypted password. Then HTTP encryption means secure communication between the client and server. Then rate limiting, prevent too many requests from one session. What this rate limiting do means, prevent too many requests from the one source. We can say the real examples. In banking apps, login is secure, the data also encrypted. Only authorized users can access specific features. Like there will be like admin login and bank admin login, like there will be there. That is the example for this security things. In banking, it will store the transaction, the amount, the data will be there. It should be encrypted. It should be protected. For that, we should ensure the security for the banking applications, the banking system. The login should be secured. Data should be encrypted. Only authorized user can access specific features. Whatever we have seen is the importance of full stack. The full stack is how the applications are distributed and the cloud native. Then also the user should have like whatever the users want. The user want the real time experience. For that, we have to fulfill them. For that, we have to make the system scale dynamically. Then security and the reliability are also mandatory. Security is the main thing to protect the user data. Then the system should be able to handle traffic. That is also important. The system failed to handle the traffic, the system will crashes. Like this is the application won't work. It will reduce the users. For that, we have to ensure the quality of the application, then the scalability, performance, usability, security, reliability. These are the important things. For every application, the important things are, for every application of the system, the scalability, performance, usability, security, reliability are the important. The validation also important to avoid duplicate data. Then protection, that is what the security. This is what the full stack, how building the scalable full stack applications. The software development life cycle, like from idea to production, the 7 stages. Through the 7 stages increase the software to build. Then software architecture, like there are types of software architecture. In this MVC architecture is the main one. Model view controller. The model is what the database, view is what is user interface, controller is the backend logic. Then there are types of architecture, application architecture, how the modern application works, like user front end and the user enters the user interface, user inputs anything, then the front end whatever user sees, then API layer, backend for handling logic, database for storing the details, then cloud infrastructure for deploying the application, backend design and API engineering. There are RESTful architecture like HTTP methods are there for retrieving the data, for creating data, for updating the data, for updating the partial data. Then there are status codes are there. The status code, after login to any application or system, we can inspect it. We can see the status code. The success, we are able to log in successfully, the 200 status code will be there. Then error handling and mechanism, error handling and validation. To prevent the duplicate or wrong data, this error handling and validation is important. Authentication and authorization. Authentication is the user identity. Authorization, what the user allowed to do. Then secure data handling. Database and design. Normalization to avoid duplicate. Then relationship, how the table connects each. Then indexing, writing good queries, efficient queries for faster response. Then scalability and performance, load balancing, horizontal scaling. Like load balancing means distributing the traffic. Horizontal scaling, adding more servers when traffic increases. Caching means for faster response, storing the frequently accessed data. And security, JWT based authentication, role-based access control, password hashing, HTTPS encryption, rate limiting. The JWT based authentication means user login secured via token. Then the role-based access control means admin has different privileges. The authorization was then security must be integrated from design stage. Thank you.